This unit is on graphing the square root and the cubed root functions. I have this slide up here though because we're just going to do a very quick review of the first couple parent functions that we've looked at. First one is the absolute value graph, y equals the absolute value of x, and the second one is the parabola, y equals x squared. These are some things that you definitely want to put in your notes, and I would also suggest you put these on your cheat sheet as well for your final exam cumulative test cheat sheets. All right, so the first one, y equals the absolute value of x. The go-to points that we're going to use for this one are -1, 1, 0, 0, 1, 1. Please remember that the shape of the absolute value graph is a V. It must be definitely pointed down here at the vertex. And the domain range for these, the domain is all real numbers. Every x number is possible. If you notice that this arrow keeps going forever both directions, that means that all x numbers will eventually get used. And the range is everything greater than or equal to 0. It starts on the y-axis and goes everywhere up. There are no negative numbers used here. The second parent function is the parabola, y equals x squared. The go-to points, if you notice, are the exact same go-to points as the absolute value graph, except this time your shape is rounded at the bottom instead of pointed. The domain is the same as the absolute value graph, all real numbers for the domain, and the range is also greater than or equal to 0. Now we're looking at the square root function. The square root function is the equation y equals square root of x. The go-to points for this one are now different. We're going to start with 0, 0, then move to 1, 1, and move to 4, 2. You might be wondering where are those coming from. Well, if I let x equal a few values, starting with 0, I'm not going to put in a negative number because I can't do the square root of a negative, for instance. I get an I term, and I terms are not graphable. So we're only going to use positive values. So if we start with 0, square root of 0 is still 0. Plug in a 1. The square root of 1 is 1, and the same thing, square root of 4 is 2. So that's where these three go-to points come from. The domain, x numbers must be positive, so greater than or equal to 0. Can't do anything back here. Negatives don't work. Greater than or equal to 0, and the range also, if you notice, we have everything that is above this line that represents y greater than or equal to 0. The cube function, y equals x to the third. This is the shape that I will call or refer to as the snaky S standing on its tail, the little S curve standing on its tail. Your go-to points, down here, -1, -1, then in the center 0, 0, and up here 1, 1. The domain and the range for this are all real numbers. I will eventually, following these arrowheads, I will eventually use every x value negative and every x value positive, and the same thing with the y value. Eventually every y value, both positive and negative, will be represented. All right, the cubed root graph. We have the exact same go-to points as the cube, except this time you'll notice that your snaky S curve lays on its side. So you're going to say side to side on this one. Go-to points are the same, -1, -1, 0, 0, 1, 1, and the domain and the range are the same thing as the other one, all reals. Now, on this particular page, you're going to want to put this on pause and write down each of these rules. These are the shifts, and for every single one, it's A, H, K for every single parent function. The first thing we're going to do when we try to graph anything that's shifting, first thing we're going to do is the H value. Now please remember, the H value moves your graph to the left or to the right, and you must do the opposite of what it says. The second thing we're going to look at, second thing, is this A value out in the front. The A value stretches your Y number. In other words, it multiplies your Y number. And the third thing we're going to look at is the K value. K value is the number sitting out in the back. That is the value that slides your graph either up or down, and you will do the same movement as what the sign says. If it says +7, you will shift the graph up 7. So this is the order in which we will be moving our graphs. First thing we'll do is change the x number. Second thing we'll do is multiply this a value times the y term. And the third thing we do is add or subtract a k value to your y term. Before we do this one, my husband and I first lived in Lexington, Kentucky when we got married. All right, on this first example, y equals x minus 1 to the third plus 2. First thing I'd like you to do is always write down the go-to points that go with each graph. Now this is the cubic graph. Cubic graph uses the points -1, -1, 0, 0, and 1, 1. First thing I remember I told you to do is inside here with the parentheses. We will do the opposite of what it says. It says -1, which means we will plus 1. So we need to add 1 to every x value. So I will take -1 plus 1 gives me 0, 0 plus 1 is 1, and 1 plus 1 is 2. So I now have the x value taken care of. I will not change that x number anymore. 0, 1, and 2 will stay my x values. Now I go to the y value. The second thing I do is multiply by whatever I've got out here in the front as a multiplier. Well, if I don't have a number, it's like a 1, and that just means that I do not have to multiply anything by the 1. I can just jump right to the number in the back. That's always the third thing we do. I will do the exact same thing as what it says. It says plus 2, so I will add 2 to every y value that I've got. -1 plus 2 is 1, 0 plus 2 is 2, and 1 plus 2 is 3. So those are the 3 points that I will then be plotting as my shifted go-to points. So we'll look for those spots on our graph. 0, 1, 1, 2, and 2, 3, those 3 points. Then I can connect them in my shape. Now remember, every cubic, every x to the third has a shape that is a snaky S curve laying on its tail. So I will make my shape, and then I answer the domain and range question. Every time for the cubic, the domain and range are all reals for both of them. All right, now we're going to do this one. The graph is y equals -2, x plus 2 raised to the third power. I start with my go-to points. -1, -1, 0, 0, 1, 1. Now I shift them. The x-coordinate, I do the opposite of what this says. It says plus 2, I have to subtract 2. So each of these x terms will subtract 2. -1 minus 2, -3. 0 minus 2, -2. 1 subtract 2, -1. My x-coordinate is now finished. I don't have to do anything else to that. Now we move to the y value. The first thing I do with the y value is look to see if I have anything in the front. I do. I've got a multiplier of -2, which means my y values will multiply by -2. -1 times -2 is 2. 0 times -2 is still 0. 1 times -2 is -2. Now the last thing I would do would be to add in a k value. But if you notice, I don't have a k value. So it's as if I'm adding nothing, which means I do not have to change my y values any longer. I'm done. So I can plot these points. -3, 2, -2, 0, -1, -2. And then I'll make my shape. Now remember, you've got a cubic graph. Cubic graph is always the snaky S curve standing on its tail. Mine happens to be the negative, which means it's just going to flip. So it starts high, ends low, still staying on its tail. And then we add the domain and range question. And if you remember, every time, both of these are all reals. The square root function. Now we have to go to a different set of ordered pairs for our go-to points. The square root function has 0, 0, 1, 1, and 4, 2 as the go-to points. And now I look to do my shifting. First up is inside here. Do the opposite of what that says. It says -3. I need to add 3 to every x term. 0 plus 3 is 3. 1 plus 3 is 4. 4 plus 3 is 7. X terms are now finished. The second thing I do, look to multiply anything I've got out in the front. Well, I don't have a number, so I don't need to multiply. I will have no stretch, no multiplier. So then I can move to my back. The back is the third thing we do. It says plus 1, which means I do exactly that. I add 1 to my y term. 0 plus 1 is 1. 1 plus 1 is 2. And 2 plus 1 is 3. And those will be my ending points. I can go to my graph and I can plot them. 3, 1 puts us right here. 4, 2 is this dot, and 7, 3 was this dot. And then remember, the square root graph is this shape, that little half arc, that's now been shifted. So I can make that shape, and then I do domain and range. My domain, the x values did not start at 0 anymore, we shifted. So I'm starting from this point, which is greater than or equal to 3. And my range is now no lower than that point right there. Every part of my graph is above the positive 1. So the range is y greater than or equal to 1. All right, now we're going to try this one, or you can put it on pause and try this one yourself. Your go-to points, 0, 0, 1, 1, 4, 2. The first thing we do is shift the x term. It says plus 2, I have to do a subtract 2. 0 minus 2, negative 2. 1 subtract 2, negative 1. 4 subtract 2, 2. I'm done shifting the x terms. Second, I multiply by whatever is in the front. It's a negative sign, so I'll multiply every y value times negative 1. 0 times negative 1 is still 0. 1 times negative 1 is negative 1. 2 times negative 1, negative 2. Now I've got one more shift. This is the third and last thing that we do. It says subtract 3, which I'm going to do exactly that. I need to subtract 3 again from every y term. My x values will stay the same. Y term, 0 subtract 3, negative 3. Negative 1 subtract 3, negative 4. Negative 2 subtract 3, negative 5. And then I can plot them. Negative 2, negative 3. Negative 1, negative 4. And positive 2, negative 5. Now remember, your square root graph typically is the little arc like this. But remember, we had a minus sign in the front, which means your arc is going to flip upside down and shift. So it starts here, flipped upside down, and shifted. Now the domain and range question. What's the farthest back we go in the x direction? Farthest back is right here, negative 2. That should match what you have underneath your radical. My x values are x greater than or equal to negative 2. And the range. Be very careful here. Your range is now underneath. Your curve is going underneath a particular spot. What is that particular spot? Right there, negative 3. We are no higher than negative 3. So I show that by saying y is less than or equal to negative 3, which is the same number as that. You should be able to answer the domain and range question before you even graph, based on what you look at in your picture. Hopefully with enough practice you'll be able to do that as well. Alright, the next one is the cube root graph. Now the cube root, remember, is your side-to-side snaky S curve, or the S laying on its belly, snaky S laying on its belly. Alright, so the first thing we do is the opposite of negative 3, which means add 3. Negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. I'm done changing my x's. Now I move to the y term. I've got a multiplier in the front. I need to take every y term and multiply negative 2 times every y term. Negative 1 times negative 2 is 2. 0 times negative 2 is 0. 1 times negative 2 is still negative 2. And now remember, the third thing we do is shift from any number that's in the back. It says plus 4, that means I have to add 4 to wherever I was just at. 2 plus 4 is 6, 0 plus 4 is 4, negative 2 plus 4 is 2. And those are my ending dots. You can look on the graph, I've plotted them, 2, 6, 3, 4, and 4, 2. And I'm going to create that same snaky S-curve laying on its side. Remember that minus sign means it's going to flip, so instead of being low to high, it's high to low, still laying on its side. And the domain and range, all reals. Cubic and cube root graphs are always all reals every time. Let's see if you can do this one. Put it on pause and try it yourself. Negative 1, negative 1, 0, 0, 1, 1. Change the x number first. Subtract 2 to the x's. Negative 3, negative 2, negative 1. Multiply the y term by anything in the front. I don't have anything except 1. I don't need to multiply, which means now I just move to here. Subtracting 3. Negative 1 minus 3, negative 4. 0 subtract 3, negative 3. 1 subtract 3, negative 2. And those should be my 3 points. Negative 3, negative 4, right here. Negative 2, negative 3, and negative 1, negative 2. This is a side-to-side snaky S-curve that goes from low to high. And my domain and range question for both, all reals. And I believe that is it. You have now had practice in the cube graph and the cube root graph. You can go ahead and go to Skyward, go to your online quiz for section 6.5, graphing square roots and cube roots.